Hi, everyone. My name is Marco D'Angelo, and I'm the developer lead for Microsoft in Italy. Today, I'll be your host for what I believe it's a really interesting session. It is related to how the Italian government is addressing the needs of its citizens with an application that, among others, is built on top of some Microsoft technologies. There will be, during this discussion, a hint of TypeScript, some Azure functions like Azure services like functions, and obviously GitHub. But I don't want to spoil too much. Just one more thing. I got introduced to this project, the EO app, in a community meetup, because guess what? The people that is here with me today, as they will tell you, developed everything in a very open way since the beginning of the project. And they've been also very open to share what they've been doing. But you will see by your own. Let's give credit to whom is deserved. And let me introduce to you Michael, Pasquale, and Fabrizio from Pagopia, the government entity that is in charge for the EO app, that will explain to you the project and the ins and outs of the technology that this is behind. Michael, the stage is yours. Please share the presentation and tell us what is your take on the EO app.
Yeah. Can you see the presentation?
Yep.
Okay. I am Michael Di Sarò. I'm a software engineer in Pagopia, and I'm a backend engineer. What is EO? EO takes its name from the first pronoun of the Italian language and means I. It's an app that helps citizens to be reached by the public administration about their rights and duties. It provides also lots of services. He is a message aggregator. It provides a payment platform and other services like European COVID certificates, bonuses for young people, and so on. The numbers of the app are pretty massive. So it has 30 million downloads, it delivers millions of messages per week, and helps citizens to make thousands of payments per day. Our challenges are very different, and a lot of challenges. We try to follow domain-driven design principles to achieve high scalability, to achieve a good knowledge of our domains. We try to achieve a zero downtime deployment and also to protect the citizens' data the best we can. All right. Here is a simple descriptive design of what service we use. It's not a very detailed view of our function apps or services, but it's just an overview of what Azure services, which Azure services we use. So we use Application Gateway to manage the huge traffic we need to serve. We use API management to expose APIs. We use function apps and app service to do business logic, Cosmos DB, blob storage, and others to store data. We have Key Vault to protect our secrets, DevOps for our CI/CD pipelines, and we use a lot analytics because we usually test on production after we do the tests, the automatic test on our code we see later, and we need a lot of monitoring of our services. We have microservices everywhere. Serverless is the king because of its automatic scalability and fault tolerance. We use a lot of function and we use almost any kind of triggers for function. We need to achieve high scalability and fault tolerance also with the storage. So we usually don't use a relational database system, but we have a strong preference for blob and document storage. Our storage is usually NoSQL, distributed, partitioned, and redundant. We We say that we are going to follow domain-driven design principle, and we try to work always by small changes and deliver them continuously in production. And we try to automate as much as we can. We say that we need to put particular attention to the privacy of the user and to their data. So we have a legal team and a security team. We co-design our services with these teams, and we try to follow all the best practices possible, such as restrict access to the resources, authorize every request, don't put data outside from the system, so data is not reachable from the outside. And we try to give the user the most control possible for its data, so he can try to set its opt-in, opt-out option and delete his data, of course. We use TypeScript to develop our code. TypeScript has a great support on Azure, and we empower it with a couple of libraries by Giulio Canti that are FPTS and IOTS that allows us to use the functional programming paradigm. Why we want to think functional? Because these help us to think more about what we want than how to do it. So we try to keep our code as a flow of function. These functions are reusable, are carefully designed to take an input and produce an output without changing data. And we keep the flow of our code into a railway, a sort of railway. Every function usually return either a result or either an error. We take testing very seriously. We use unit test, integration test, and end-to-end test before going to production. And we also have reviews, as we see later. I will give on slide 11 an example of a functional vs imperative. So if we take any data source in input, any JSON, arbitrary JSON, we should check if there are some property. With FPTS, we can define some structure. They are defined codec, and we can do all this if with just the structure codec.decode function. As you can see, the functional example is more verbose, but the benefits are great. We can really think what we want to obtain. Our code base is open by company policy. You can see it at GitHub. Just scan the QR code and you will be directed to our repository. We take suggestion and feedbacks very seriously, and we follow a very strict release pattern. So we usually transform our stories to pull request. Every commit is a task, subtask, or another activity correlated with the story. And then after all the automatic tests are done, we have linting, we have tests to be done by some pipelines. We also request a human review for our code. If the human review pass, we are ready to merge to the main and then launch a deploy pipeline. I leave the word to Pasquale De Vita that will talk you about our infrastructure. Thank you.
Thank you, Michael. Can you still see the screen? Okay. Thank you, Michael, and I'm Pasquale, and as a senior DevOps engineer, my mission is to design and implement secure and high-scale environments which runs Pagopia application. So we are going to see how we configure our cloud environments needed by a modern application that need to grow fast. If you think that there are a lot of microservices, we also want to create a consistent environments with high quality standards. But where are our challenge? We need to deliver stable environments fast and at scale, where at scale we not also indicates that our workload. Also, we at scale we intend also create a lot of microservices in strict time. Also, we need to create a repeatable process in this way all our infrastructure, all our services are configured in the same modality. And this enables the self-service infrastructure, so the team can create this infrastructure and configure the services in self-service modality. And finally, we want to prevent the runtime issues caused by configuration drift or missing dependencies, that when we create a lot of services, there are a lot of configurations. So from the beginning, we used the infrastructure as a code approach that we gain us to apply the software engineering best practice to configure cloud environments and all related tools and all application settings. With this approach, we enable the repeatable process. We can run automation script, so we can automate our code, and we can reuse the code using a model. So the code, we can share the model with our application, not only your app. Also, it's a code, so we can enable a peer review, a human review, and track the change in our system versioning. Also, the code is visible to all, and we saw the transparency. It's another important feature enabled. And as we mentioned before, self-service infrastructure. So all teams can create this environment. Security scan and compliance. Which tool? Our main tool is Terraform. That is a cloud agnostic tool used to provision cloud native application across all major vendors, but not only cloud environments, because we also use Terraform for Kubernetes configuration, a policy configuration. For example, we have a repository to create Pagopia policy to enforce, for example, the Azure region which can we deploy the services. So we configured only North Europe, West Europe, and some global services. Also, we have a repository. This is private repository where we configure our permissions. CI/CD configuration, and in particular with Azure DevOps configuration, and we use infrastructure as a code and Terraform to generate SSL TLS certificate for Azure, our Azure public services. But now we see how we provisioning the cloud environments, but this process is quite similar to where we apply application change. So we have a repository, a system versioning with only one branch, the main master branch. And the developer, when need to create a change, create a feature branch with small change. This is important, create a small change because the code is more simple to review. So a developer open a pull request on GitHub with the proposed change. As the time, a pipeline automation check the source code with the analysis, with a static analysis, and also a preview change. The preview change help the reviewer to check the change and approve the pull request. Finally, a developer can run a pipeline to apply the change, and the notification is sent to the team. This is a little overview of our pipeline for infrastructure as a code. All the code is on GitHub, so Terraform code is on GitHub, and the static analysis we use the GitHub action for security reason. In this way, using the third-party tools can touch us to Terraform state that is on Azure. Also, so we run the static analysis in GitHub action with the GitHub action. But when we need to deliver our infrastructure and our services, we need to access a private virtual network. And we use, in this case, Azure DevOps. But Azure DevOps can touch us direct to virtual network because it's private. So we created an Azure DevOps skill set named Azure DevOps Agent to run Azure DevOps inside our virtual network. And so in this way we can apply the change. Now we want to show you a super complex example. No, it's very easy. It is how we configured the static analysis, because we believe the engineer's time and product quality are the most valuable resources, and so the automation is not an option. How it works, this workflow with GitHub workflow. We run, we initialize the Terraform. We run Terraform init inside the Terraform folder, and and in the second part we run the test using a pre-commit, dedicated for Terraform. The goal is the pipeline is to check Terraform format, a Terraform documentation, run a Terraform validate, and finally a TF scan. We can see the pre-commit configuration that is 4-line code, and we match 30-line of code. We run this pipeline. Can be useful when we run a lot of peer review. And finally, I want to show you the infrastructure as a our infrastructure as a code base references. We have e-infrastructure repository with where we can see all the our services used by EO for Azure. Also, we have a dedicated repository for Azure DevOps pipeline configuration. And we created the shared modules for modules and policies. Pagopia modules is a module for Terraform modules customized by Pagopia, because sometimes some resources like Azure function a lot of configuration. So we created a dedicated module to reuse in our all other products, and a repository where we defined the Azure policy. For me, that's all, and I want to introduce Fabrizio if there is.
I think I have to substitute it. Should I go?
Marco, yeah. Or Michael? Yeah. Michael, continue.
Yes, let's go, please, okay. Michael, go ahead.
Okay. I'll try to explain Fabrizio's part. Let me. Can you see?
Yes.
Yes. Yes.
Okay. Fabrizio part covered a nice example about how we scaled, how we used Azure services to achieve automatic scalability, even in various incoming traffic, and it's related to the European COVID certificate. In Europe, the IO app was among the official channels chosen by the Italian government to deliver the certification. The difference between IO and other channels were that other channels requested the user to get his certificates. App.io delivered it directly to the smartphone of the users. So there was no request, no paper, and it was a complete digital service. The challenges of the European COVID certificate were related to the strict time to market, because when the government decided to distribute these certificates, they were already a lot and there was no platform to deliver them. We had to minimize the sensitive data because it's health data, and we had a huge amount of messages accesses. And there was also a rapid evolving situation, and we had to adopt some temporary measure, and we were just sailing by sight. This is how it worked. We delivered some functions right for the European COVID certification that were called by the health department of Italy. When the health department called API management and arrived to the functions, we informed the app that the certification was ready. So with a code, the app communicating with its usual channels, so services, push notification, and so on, retrieved the certificate for the citizen itself. The real problem was that at the start of the first day we released this feature, we had already 45 million certificates to deliver. So we planned a continuous deliver job that taken all the previous certificates and sent them with the new incoming certificates. This is a graph that represents the certificates sent from the health department and the certificates that we sent to the citizen. You may argue that the health department send more certificates than those we deliver, but there is a reason. It's a citizen choice, so we cannot reach citizens that don't want to be reached. So we don't have in the app all the citizens, and some citizens also give their preference. This is what I said before. We give the citizen the choice to be reached from the public administration. But this graph, returning a moment to it, explained that every day there was a huge quantity of messages to send. It was a tough year because the pandemic trend, the government choices, restrictions led to a different trend of messages. We had to send more messages a day, less another day, and so on. So here the cloud, Azure Cloud came to our service because everything scaled automatically and was downscaled when not used. So we were able to keep costs and to send loads of messages when necessary, and it didn't had any flexion, so functions scaled like a charm. Here are a few graphs that Fabrizio was more able than me to explain because he prepared them. I'm so sorry that he can't present his part, but this is the trend. a day 6 million, another day 2.5 million, another day 7 million. So 10 million a day. And this is a very incoherent trend. So function did our work. We didn't over provision anything, and the function scaled as we said them to scale. Another point is this: why we made the function for European COVID certificates. We also made a resource group about it, because the day we want to remove it, we just can remove it with one click. So we can shut off the feature when we want. The serverless worked like a charm, auto-adapted to the trend and to the changing environment, and we also were able to do some modification while running. So it was really a tough work, but it was a lot simplified by these design choices. And I think it's all. Thank you.
Yes, thank you so much, Michael and Pasquale. Like the audience has understood, we had an issue with one of the speakers, Fabrizio, that I want to thank you, and he was able to join because of some issues with the platform. Having said so, thank you so much to all the PagoPA team, because as I was mentioning, this project is a very impactful one, not only because of the number of people that is involved, but also for the security and the complexity that runs behind. And taking a look at the questions that we are going to ask now that we more or less have finished the discussion, always in writing, the scalability part has been massive in terms of the requirement from the application side, and has been covered using a couple of words that we shared with Fabrizio during the rehearsal. Basically, there were an order of magnitude of spikes in some cases, and the people working with that basically didn't even realize, because the infrastructure based on function was able to scale without so much issues. The important part, let me say, is that if you can take a look at the chart, I've posted the repo that Pasquale was showing up in the slide. Is that everything it's open source, so you can take a look at the code, looking up what's going on, and as I was mentioning, we will be replying to the questions. But if you want to stay in touch with the speakers and getting some curiosity sorted out, I'm posting out right now also the contacts in terms of the LinkedIn profiles of Pasquale, Michael, and Fabrizio too. So that you will find here in the chat. Thank you so much, everyone, and I hope you will enjoy the continuation of Build. Thank you and bye.